Today I thought I would just briefly go over what is a lake house. And there's lots of hype around it and lots of marketing and messaging and so on. So today I thought I would just briefly kind of go over it and dig into what it really is and why you might want one. So one way of looking at the lake house architecture is that it is the next logical step in our data evolution following the creation of data lakes. The reasons that I say that is that it brings the best features of both worlds. So in the case of the data lake, it brings the benefits that we see in low cost, the support for structured and unstructured, as well as semi-structured data, and that it is accessible by many applications, and that list of applications that it can be accessed by is growing continually. It also brings together the benefits that we get from a data warehouse. It serves as a single source of truth, meaning that you can trust it. You believe that it is valid and appropriate for business use. And that means that it's been highly curated. There have been a lot of business rules applied to it, ensuring that what's inside of it is true and accurate. It does support scalable queries, so lots of people can use it, and you can use it for different stuff. So taking a step back, what's a data lake, right? Because you may or may not be that familiar with it. It is a way of using low-cost storage, such as object storage in cloud providers, as an example. Generally speaking, it's based upon HDFS, Hadoop's file system. Part of it is that we had these data lakes that were essentially HDFS repositories. We figured out, hey, that's a great place to store stuff outside of what it may be really needed for a particular Hadoop job of some sort. So we started using it. A data lake is also distributed. That's part of the essential part of doing something like Hadoop-based operations such as MapReduce and so on, is that the data has to be essentially shared across or spread across multiple nodes in some sort of a storage fabric with some degree of fault tolerance built in, and that fault tolerance in this case is provided by some sort of algorithms, and it's essentially unlimited because of this architecture. The main limitation is going to be the cost. How much can you afford to pay for the storage? And it's generally speaking, we do these things in the cloud. So you can have an on-premise data lake. They're pretty rare. So normally they're in a cloud provider. And one of the key elements is that data lakes are very accessible by people doing data science and machine learning workloads. That's one of the important reasons why they've gained adoption, is that it allows you to do analytics at scale, which is essential to be able to harness the value of your data. So what's a data warehouse? And you probably know this one: highly curated relational system. There's a very rigid structure to this data. The schema is very well organized and designed and is there for a reason. Data is cleansed at the point of ingestion. So when you're ingesting data into these data warehouses is when it's applied. We optimize these data warehouses for read. So it's all about getting the data in a way that can be accessed quickly by multiple people. Generally speaking, it's using a dimensional model of some sort. They are pervasive. We have data warehouses in most organizations, but they're not terribly easy to get data out of for data science and machine learning workloads, and that's one of the limitations, is they're a little problematic for that. So why do we have a lake house? Returning back to the question at hand, and you can think of these in terms of supporting and challenging forces. So supporting forces in this case is the combination of low cost cloud storage, data quality, or data query capability. So we've had a lot of optimizations in queries, and the application of a schema using Delta Lake and very simplistic sort of data quality rules that are typically sufficient for most organizations. And this data is also accessible by JDBC and ODBC, the common connectivity mechanism used by a lot of tools, including things like Power BI and Tableau, which is part of the reason these things are very predominant as well. So a lakehouse is made up of basically a storage layer. You have the data being persisted somewhere. In this case, it's in a data lake or some blob storage with Delta being applied on top. And Delta is essentially a relational layer on top of a data lake that lets you do things like impose a query or a structure onto it, a schema onto it, and highly optimized types of queries. Organizationally, we use zones of refinement. inside of a lake house. And those names are very specific and have a specific reason and definition. Bronze, for example, is where the data lands initially in your lake house. You can think of it as being a delta version of your source data. If you have systems that are transactional in nature that you're retrieving data from, meaning you do make updates to records, there will be multiple records inside of the bronze layer, each one of those persisting the change that was made, and you need to be able to organize those by date so that you know the most recent one. Silver takes data from the bronze layer and then turns it into something that can be used by the organization, so it becomes fit for use. There's an application of business rules typically at this stage as well, and you can view it as essentially the most recent version of the data. It should be almost identical to what's in the source system, and it is what you would typically use going forward. A key construct here is that zones only typically go from either themselves to themselves or from the zone before them to themselves. So bronze to silver, you may have a silver to silver operation where you take data from a silver table, turn it into another table in the silver zone as well, and then at some point you're going to construct gold tables, and those are tables that are built to answer a specific question. So if you have a dashboard or a report that needs an answer, you're going to build a gold table for it, and that gold table will be constructed using either other gold items or silver items. So that's the basic way that we lay out our stuff. This is to simplify the various flows that you can see if you do traditional ELT type operations. We're basically reducing the complexity and simplifying it. On top of all this, so that you can, or enabling you to access all this stuff, is a compute layer. And that's typically a Spark-based engine with delta optimizations as well. So it serves the data that is going to be accessible outside of the delta or out of the Lakehouse using these endpoints. So Power BI, Tableau, and such is going to hit the endpoints to retrieve the data. So next, what's next in this journey to a Lakehouse? First of all, go buy my book. It'll be available shortly. It will help you with the common things that you encounter whenever constructing a lake house. After you have that, at some point you're going to want to design your lake house, and then you're going to start building it. Generally speaking, you build it with some sort of tools. You may use Databricks only tools, but likely you'll be using some other tools to simplify the ingestion. Refinement, generally speaking, will all be done inside of Data Lake. Thank you for watching. I hope you have a great day. I look forward to talking to you again soon.